Hi, so today somebody sent in 3 boards and they asked that I do a video on how I solved some of their boards. Now, let's get started with one of these. So, one of these is a 17-inch that randomly turns off, that is from 2008. Yeah, leaving that one for last because the chip that is most likely at fault there is not available new. So, I'm going to be cursing as I solder multiple onto the board to try to fix a problem, and I will be chasing my tail for a very long time on that one. The other one is a retina. I don't really want to ruin the end of my day starting with a retina. So I'm going to start with this. It says that there is no light on the charger, dead, and that there's a chip missing near the MagSafe. And this is also for somebody who's going to be coming to the school that Jessa and I are having. And to reiterate what the school is offering, because again, a big question has been, what are you offering in the school that you're not offering on YouTube? And again, my answer is nothing other than one-on-one instruction. It's nothing other than me showing you the content that's already here. Because I'm going to show you the answer to how to fix this board is already out there in my content. It's already there. All you need to do is find it. But since I have these hundreds and hundreds and hundreds of hours of content all scattered about, a lot of people don't really know where to find it. But if you had found it, you would have been able to fix this board yourself. And I'm going to show you what's going on with it. So when I plug it in, I get no green light in the charger. So let's go over and see what's going on with the whole no green light in the charger. This is an 820-2530. And I'd like to start with something called a one-wire circuit, which I've talked about many times. So what this circuit does is very simple. This over here is your DC power jack. This here is the MagSafe charger. Now, when you go to buy a PC charger, you may see a lot of them at 10 or 20 bucks. You go to buy the Apple charger and the things like $70 to $120, and you may wonder why that is. And it's because that charger is a little bit smarter. So over here you have a line called adapter sense. This is going to communicate with the system management controller so that they can talk to one another, unlike what you get in a conventional PC. In a regular PC, the charger pretty much has fault detection, where if it sees a short, it just turns off and that's it, or it's on. But the charger itself is, plus 18 or plus 20 volts and ground. It's 2 conductors. Here you have more conductors so that you could send information back and forth using the one-wire protocol. Now, the way this works over here is this is the adapter sense pin. That's the pin that's going to be talking to the computer. Now, it's going to use the sys one-wire line to talk to the SMC. And if you want to know how it is I understand this, what I did is I hit Control F in my PDF reader. And after I hit Control F in my PDF reader, what I do is I hit Enter. And it shows me that sys one-wire here is a bidirectional line. That's what bi stands for. So you have in, out, and bi. Bidirectional means the line both sends and receives information. And this here is the SMC. This is the system management controller, the U4900. You may wonder how I know that. Well, it says SMC all over the page. It says SMC on the bottom of it. You just use your brain a little bit. So that is what talks to the SMC. Now, how does this work? Let's take a closer look. Over here, there's this chip where you see it has the external communication from the charger, the internal of talking to the SMC. So the way you can pretty much devise that this works is that this will travel to here. Now, what's going to happen here is it's going to be communicating using a pull-up resistor. And you can go to my basic electronics section to see what a pull-up resistor is and how it allows you to have a data line. So this resistor here is a pull-up resistor that allows this sys one-wire line to exist. And it's coming from a 3.42 volt power supply. How do I know that it's a 3.42 volt power supply? Well, one of the things that you'll notice if you look at a lot of these schematics is that a lot of these little chips, a lot of these ICs have VDD or VCC or VIN, and the VDD pin or the VCC pin or the VIN pin is voltage in, or I honestly don't even know what VCC and VDD stand for, and frankly, I don't care. I just know that 99% of the time when you're looking at a schematic like this and you see VCC or VDD, that's the power input on the chip for it to actually turn on. Now, how do I know this is 3.42 volts? Because it's coming from here. Now, what does this thing do? If you don't know what this is, you can simply Google this number, SOT665TC. I'm going to go blind if I try to fucking read all that, so I'm not. You can Google that, and you'll be able to find that that's a 3.42. That's a logic gate that's going to allow the 3.42 volt power line to go through to this chip and power this chip, assuming that SMC, BC, ACOK is there. That's the way a logic gate works. If you have input here, allow this thing to go through there. If you don't have input here, don't allow this to go through there. A logic gate is very, very simple. This is a very, very basic logic gate you have here. And that's that. Now, what is SMC, BC, ACOK? Well, let's see where it shows up on the board. So this shows up by the SMC. This shows up here where it changes into charger ACOK. So over here, charger ACOK is something attached to the U7000 chip. And the U7000 chip just so happens to be the battery charger and the power bus supply. So this takes the charger and turns the charger into 12 volts for the machine so that it can actually do work. This controls the charger. This controls whether or not the charger voltage will be going through to the machine. So you kind of see where this is all coming into play. So let's say this chip does something terribly, terribly wrong, and it's sending power through when it shouldn't, or the chip knows that it shouldn't be sending power through. What it will do is it will turn SMC BC ACOK down, and that will disable the U6901 from sending power to the chip that allows the MagSafe to talk to the computer. So to make that short, if the charging chip notices that something is fucked up in the machine, it will disable the charger from being able to talk to the computer, which will then disable the charger from working, which will get rid of your green light. So what does this have to do with this guy's specific problem? See, U6901, that chip is supposed to be on the board in a specific spot, and when I go over to his board, what do I see where U6901 is supposed to be? But nothing. And this is what this course is going to be about. This really is, because again, none of you people are real who want to take this course. None of you are dumb. You all have a desire to learn all this stuff, and you're all deciding to travel and to spend money to learn this stuff. And you actually have the brain power to put together enough basic information to realize that this is something that you can do. And you're right, this is something that you can do. What this course is going to do is it's going to take all this information that I've scattered across there, and what I'm going to do is I'm going to pick at you to remove all these little things that you don't understand individually to make sure that you have a greater understanding of all the content I've done. That's the point of this. Again, a lot of people say, well, you already have all this information up there. What's the point of a class? And when I get a board-in like this from somebody who is an intelligent person, this is what the class is for. You're not dumb. You're just missing this little piece of information because somewhere inside of hundreds upon hundreds of hours of videos, you decided you're going to go do something else. And I really don't blame you. So what I'm going to be doing is I'm going to be going through boards with you, and I'm going to be going through concepts, and I'm going to be trying to figure out what it is that you don't understand. I want to figure out what is it that's keeping you from doing something that I know how to do. Because again, I may have explained it, but you may have misunderstood my explanation. I may have done a poor job of explaining it. I don't know what it is, but there's something there that kept you from understanding it. What I'm going to do is I'm going to eat away at all those little bits of misunderstanding. That's what I'm offering in the course. And that's what you'll be paying for. Okay. So what I'm going to do is I'm going to get a logic gate from another board, because hell, again, as I said, hell if I order this crap off Mouser and DigiKey so I can wait a week or 2 weeks, have them send me the wrong shit, or have me buy the wrong shit and then realize that I wasted my time. That is of no interest to me. What I do is I have parts boards here that have all this stuff already, and I go from there. So first things first, obviously I have to put back what is missing before I can hope to do anything else. Okay? Oh, yeah. Would help if this was here. Sure that solder is enjoying its place in my lungs right now. Ugh. Oh, disgusting. Okay, so we're going to take that chip from here. We're going to put it here. Bonus points for not destroying the LCD connector while doing this. But who am I kidding? Some plastic is going to get melted. It's not going to make a difference or matter any which way. But okay, so now let's see if we have any difference in our troubleshooting process. Let's see if anything has changed and if the board works. So first things first, we plug in the MagSafe, and let's see if we have a green light. Oh, no green light. Okay, so let's see what's going on with the board and what else could be wrong with it. So I'm going to take my oscilloscope because I don't feel like bending over to turn the multimeter on right now. And let's see what voltages I get at different areas on the board. PP bus G3 hot is straight up 0. Let's see. My 3.42 volt rail is 2.3 volts. So this here is Yeah, this is going to be some bullshit. And yeah, this was going to be. Wow. Now, I wonder why my 3.42 volt power supply is not working. So I checked a couple of power rails here to see what was going on. Let's just go back to the schematic because people are always going, where do you find this stuff? So let's see. So I checked my PP3V42 G3 hot. Let me show you where the list of power rails are here. So here we go. This is a good list. So we have lists of different rails, power rails that are supposed to be present in the computer. Now, PP bus G3 hot, which is supposed to be 12.6 according to here, is 0. However, PP bus G3 hot, remember, we're not going to get anything on that rail without the one-wire circuit working. Now, in order for the one-wire circuit to work, we need PP3V42 underscore G3 hot. This actually comes on before the charger does, and instead of being 3.42 volts, it is 2.3. I just measured that as 2.3. Now let's take a look at the space on the board where that shows up, right? So let's go for PP. Let's just find this and see what happens. Okay, come on, bring me to what I'm looking for. Come on, PDF reader. You can do it. Oh, seriously? It was right here all along? Okay. So this is that power supply, right? So let's open up this board in the board view software and see what's going on. So CU6990, L6995. So the inductor is on the bottom of the board, and this is on the rest of it is along the top of the board. So first thing I want to do is let's see if there's. First thing I want to do is punch whoever made this software in the face, but that would probably get me in trouble. Okay. All right, so let's see what that section of the board looks like. So okay, so this here is the PP3V42 underscore G3 hot power supply. And also let me just show you a little bit of the listing of the power rails. So a lot of people will ask me, how did you know what to check? So if I search here, we have a page over here that gives you a list of different power rails that should be present. SO rails, they should be present when the computer is in an SO state. If you don't know what states are, you can look that up on Intel's website. SO is on, S3 I believe is sleeping, S5 is hibernating or off. I don't really remember off the top of my head. But these are rails that should always be there. So this is 3.42 volts. I checked and I have 2.34. And as I showed you over here, I need this PP3V42 to be here so that this chip will allow my charger to talk to the computer. If that doesn't happen, then I won't have anything going on with my U7000, which means I won't have 12 volts, which means I won't have anything else. So what I'm going to do is I'm going to go back and let's take a really hard look at my PP3V42 power supply. So that is controlled by U6990. So I'm going to go over to my board view software and take a look here at U6990. And then also, I'm going to look at the board. I want to see what the board looks like at U6990. I don't know at what point this keeps switching back to the microscope. I think that has something to do with when I hit Control F, that's... Okay, so I'm not sure how much of the explanation you're actually able to see, but I really just can't go back and re-record this because I'm sorry, I just don't have the time. Maybe it's just having the hotkeys. See, this is why I don't like to change things in my setup. Like, so many people are going, why don't you get the hotkeys? Why don't you get the hotkeys and the scenes? And it's like, this is why. I like being able to manually control it. But I don't know. I don't remember hitting Control 4 or 5, but apparently I did. So let's see what that section of the board looks like. And, oh. Yeah, does that look like a healthy motherboard to you? Does that look like a healthy 3.42 volt power supply to you? No. And if I were to guess, I'm pretty sure those resistors in the right over here are for feedback. So U and for U. I'm going to bet that you two are feedback. So what do I mean by feedback? Well, let's see if I can show you in the PDF without it fucking switching again without me telling it to. See over here? This is a DC power. This is taking a higher voltage and turning it to a lower one. It's a standard switching DC power supply, DC to DC. So you have the voltage input. It can be controlled by either, it can have an input of 18 volts from the charger, or it can have an input from the PP bus G3 hot from the battery of 12.6 volts. So what's going on here is it has the input from either one of these. It can't have both at the same time. That's what this diode is here for, by the way. This is important. So when you have the charger plugged in, you're going to have PP bus G3 hot. When you don't have the charger plugged in, you're still going to have PP bus G3 hot as a result of the battery. So when the charger is plugged in, this is going to have two inputs, and that's very, very bad. So this whole thing is here to make sure that only one of these gets through, and whichever one is higher is going to be the one that gets through to the chip. So once you're in over here, SHDN does what the ton pin does on newer versions of this power supply. What it does is it sets the switching frequency of this power supply. So as I showed you, a switching power supply, I got to show it to you. Even though I've done videos on this before, you're not, realistically speaking, you're not going to go through and watch them. The way a switching power supply works to make a higher voltage into a lower voltage, it doesn't take the higher voltage and actually lower it. It just takes the higher voltage and takes it, and instead of giving you a constant higher voltage, it gives you this much higher voltage, then nothing. Then this much higher voltage, then nothing. Then this much higher voltage, then nothing. And when you average out those higher voltages with the nothing, for example, like 12 and 0, 12 and 0, 12 and 0, that averages out to 6. Whereas 12, 12, 12, 12, 12, 12 averages out to 12. You understand? Or 12, 0, 0, 12, 0, 0, 12, 0, 0 averages out to 4. 12, 0, 0, 0, 12, 0, 0, 0, and so on would average out to 3. That's how you take a higher voltage and turn it to a lower voltage. So to give you a visual representation of how that works, I'm going to go over here. I'm going to plug this in, even though it's not working right. It's still doing some switching. And you'll be able to see it on the oscilloscope. I'm not going to get up and zoom because, again, I've done this in other videos and I got other stuff to do here. But what I'm going to do here is show you what the switching looks like. This is why an oscilloscope is a good tool, because you don't really need this, but it's good for learning. So you see over here, you have voltage, and then you have nothing. And then you have voltage, and then you have 0. And then you have this, and then you have nothing. Then you have this, and then you have nothing. So what this is doing over here is it's switching on and off. So it's on and off, then on and off, and that's how a switching power supply works, to make a higher voltage into a lower voltage. So now what am I talking about with this whole feedback nonsense here? What do I mean by that? Well, the way a lot of these circuits work, that's a new hard drive that I just dropped on the floor. Oh, well, what are you going to do? And the way that this works is by having feedback. So feedback is going to tell this, what is this actually doing? So this chip is switching and it's doing what it's supposed to, but the chip is going to want to know, okay, so what does my output look like? Like, I know that I'm switching, but how do I actually know what my output is? It wants to see where it's going. Not having feedback on a circuit like this, to make it a really silly, oversimplified explanation that audiophiles are going to scoff at, it's kind of like riding a bike with your eyes closed. You'd rather ride a bike and see where you're going. Just like this, you're pedaling, but you want to see, is there a car in front of me? The same way you want to see what the output voltage is over here. So on the output, so after the inductor and right at the same points of the smoothing capacitor, by the way, anytime you see these dots interconnected by a line, you know that when you see dots interconnected by a line, or like this over here, that all of that is soldered to the same point. What this is doing is it's sending that back to the chip on the feedback pin, but a much lower voltage. And it's also a much lesser current. It's not going to change anything in the circuit. Again, you have this voltage divider going to ground, so the signal going to the feedback pin is going to be lower, but also in voltage, but also since these resistors are so high in value, 348,000 ohms, you're going to have it's going to be negligible effect on the circuit. So this over here is what's called a feedback network. Even though it's only 2 resistors, that's still technically enough to be a network to send this power back to the chip on the feedback pin. So if I look on the schematic for R6995 and R6996, I'm pretty sure that when I find R6995 and R6996 on the schematic, that what I'm going to find is that those 2 resistors that I was bitching about before are the ones that are blown. This is the cool part. This is where the scenes in Open Broadcaster is really going to get interesting, because I can show you 2 things at the same time. I know, it's cool, isn't it? So let's see. So remember, these 2 are the resistors that I'm bitching about, right? Those 2 are the ones that I think are fucked up. And let's see if those are the ones that the board view says are I have to reopen the board view. It's doing that thing where it's not drawing the blue lines because it's some 1995 trash software that doesn't want to work with modern versions of Windows. Oh, let's see. So let's see, R6995, R6996. And what do you know? Well, those two resistors look like shit. So the first thing to do is to replace those two. But also, what I'm going to be doing is I'm going to be replacing this. Now, this works. The power is obviously getting through it, which is R6905. Let's see. So R6905 is over here. This allows the charger power to get through to the diode and go through here. But, like, come on. Do you believe that this is passing electricity? This looks like crap. It has a look at it. It has a fucking hole in it. I mean, it's done for. So this is where, again, I haven't taken out my multimeter to measure these resistors. A lot of people go, how do you tell that the resistor is bad? How do you tell that this is bad? But I didn't notice that you couldn't see in the camera that this had a hole in it. This is what I'm talking about. That's R6905. Look at it. Look at it. So that over there is this. So see this R6905? This over here is what you were looking at. And it's disgusting. It's gross. So again, people ask me, how do you know that this is bad? How do you test the resistors? You know how I'm testing the resistors right now? With my eyeballs. I have no intention of measuring any of that horse crap. What I'm going to do is I'm going to take that garbage and toss it off of the board and toss it onto my floor and then replace them. Again, I don't care what the values of that are. I'm not going to waste time reaching for multimeter probes at this juncture. I really am not. There's no point to. My common sense and my brain tell me that those are fucked, and I trust that. And you can see. Let's see when I remove those resistors. Do you see what this looks like? Look at that shit. That's gross. That's disgusting. That needs to go in the trash. And so does this. Now the fun part. Every single year of this thing, I don't know if it's every single year or every other year, they all use a different PP3V42 power supply. They all use a different controller chip, and all that shit changes. And this board here is 6.5 years old. So this may come as a surprise to some of you, but I don't have a bunch of 6.5-year-old boards just lying around here. So I'm going to have to go hunt for one, and as I go hunt for one, I'm probably going to have the camera off, because this is going to take some time to find this in my shit bin. But before I get around to that, I'm going to tin the pads over here, try to get rid of some of the garbage. Right, we'll be able to clean up the nastiness later, but at the very least, the pads themselves are clean. So what I'm going to do now is I'm going to try to find an 820-2530 board that doesn't look like crap so that I can steal some components from it. One of the things that drives me nuts more than anything else is switching between board views. So I'll have like one board view open and another board view open, and one schematic open and another schematic open. Even with 39 inches of space in 4K, I still hate it. So let's see if I were to try to steal these resistors off of a board that's here. I'm just going to try just to prove how miserable it is. I need 348 kiloohms and 200 kiloohms. So let's see. So I have a bunch of 3115s behind me. Let's see. Maybe I'll actually get lucky. And just because I'm on camera, it's going to prove me wrong and make me look like an idiot. That's how this usually works. Okay. So let's see. 348 kiloohms, right? I need 348 kiloohms. And of course it's not there. Let's search on a different type of board. So let's try 30. I have a bunch of 3330s behind me. Let's see if that has any 348. 348. Of course not. Let's see if I can get a 200K one, at least for the bottom. Here we go. R3891. So at least one of these I can get. So this is where my brain just starts melting when I have all these windows open. All right, so R6996. I got to go here. R6996 is the top one. I have to remember this is the top one. This is why it's great to just have boards that already are the exact same board that you're working on. Because again, one of the things that makes me productive and allows me to make money is having a really fast workflow. Meaning that I'm not, again, the time that I'm spending looking this crap up and then opening different board views, and then switching back because I forgot which resistor I'm looking for, R3891, it's time that you don't spend actually getting stuff done. And that, so. All right, so I'm going to grab this little thing off of a 3330. And, okay. So what was I looking for? And we continue our search now for a 348 kilo ohm resistor, which is probably only going to be on a 2530, which I really don't want to go digging through bins to try to find some 6-year-old shitboard. Let's see. So where do we find that? Let's see. Does a 2936 have that? Let's see what we... Oh, no. Wrong one. I'm sure somebody will jump into this video and troll and say, you should have resistor kits with every single resistor already there in the spool. You don't, you're unprofessional. Okay. Yeah. Let's see. Maybe in my really old collection. So this is a 2009 board. I have a pile of 2523s. Let's see what's in the pile of 2523s. Tell me you use the circuit. Come on. Okay. Oh, thank you. Here we go. R6063. So R6063 on a 2523. R6063 on a 2023. R60s. Oh crap! I forgot. Okay, so I forgot the resistor already. That's the type of memory that I have. That's what I'm working with. R6063. So R6063. Here we go. Oh, you're small. You're small. Okay, so we're gonna steal that. Wait a second. Oh, you're no stuff. Huh. Okay, so it doesn't say no stuff. Sometimes there's stuff in the schematic that doesn't actually exist in real life. And when that happens, it'll say no stuff on here. But on here, it doesn't say no stuff and there's nothing there. Well, that's a... Oh, you just got my hopes up for nothing. Okay, at the very least, here we go. So it uses the exact same supply here. So great. So I can grab R6905 and R6995 from here. So R6905 and R6995. R6905, R6995. Great. Great. I've already stolen them from this board. Okay. Get another one. All right. So first things first, let's remove... Actually, I don't have to remove anything because I already did all that work. So let's see. We're going to take the right resistor all the way to the right and all the way to the left. I never changed back to the screen capture software, so you never got to see me browsing around. Or maybe I did and it changed back to the microscope. Who knows? So obviously, it's about time I get a separate monitor for the dash just for open broadcaster so I can see what you see. To make, I don't know if it's out of my own forgetfulness that I'm forgetting to change the scenes, or if the scenes are changing and just fucking with me, or if I don't know which of the above it is. But if I give a second monitor, I will be able to find out fairly quickly. Either way, that's spending more money for YouTube stuff that can most certainly wait for another day. Ah, whoa. Okay, a spider just started trying to crawl on my arm. So right behind here, you can't see in there's windows, there's a bunch of trees, and there's a whole big garden and everything in the background, and there's spiders, and when the little creepy crawly things, and when the weather gets better, they come here. And they usually bother me when I'm soldering something really small. All right, then what comes next is that big resistor. It just solders itself. See, that's the magic of a good iron. So what a lot of you people who are using that IOE bullshit don't understand, or the crappy ones, when you have a really small tip, like a really fine tip like this one at the end, and you can shoot out a lot of air, you can really focus it in one area. I don't even have to align that properly. I point it in that direction. There's good solder with good flux already inside of it that's there, and it's healthy. I just do this, and surface tension brings everything to where it's supposed to be. So let's see. Do I have any better results now? Microphone. Let's see if I have anything better. So I'm going to plug the charger in, and let's see what I have at some different points. Okay, so what happened there when I plugged the charger in is that this actually went up in smoke. So that resistor that had the hole in it, I don't know if you were able to see the smoke in the room, but it just smoked. And there's probably a good reason for that. So what I'm going to do now, I'm going to remove this resistor because it's obviously fucked. And what I'm going to do is I'm going to try to measure for a short on both sides of it. And if I see a short, I'm going to wind up injecting some current into it to see what's going on. So let's see. Now you can't see the multimeter because I was so sick and fucking tired of the thing falling down all the time that I glued it to the. I used this industrial tape adhesive thing to bond it to the wall because I was so tired of the kickstand falling down. So I got my multimeter probes here. I'm going to take my red probe and put it on ground. I'm going to take my black probe and put it on each side of this and see if I have a short. So on one side I have OL, which is totally fine. And on the other side I have... See, this is where it gets kind of confusing because on both sides this thing measures OL. But for that thing to actually go on fire... Maybe there was just too much flux so it wasn't making contact? Now this makes no damn sense. Okay, well perhaps... That's interesting. So let's check for a short on some other portions of this, right? Okay, so let's look at this logically. So this thing is burning right now. Is this chip shorted to ground? Is this capacitor shorted to ground? Let's measure some things and check. So let's see. What does C6990 look like? Let's see. What's C6990 doing? C6990 is on the bottom of the board. Yeah, this is great. And here I picked this one because I thought it would be easy. That's exactly what I get. I get what I fucking deserve. I'm going to avoid the retin in the other one because this is a simple one-wire problem. I'm going to be running one wire and fixing it and looking like a genius. Yeah, right. Okay, so no short to ground there. In diode mode, I have 0.543 on my multimeter, which means there's a 0.543 voltage drop across it, which is pretty high and good enough for me. So I'm just going to go through some points in this circuit and try to figure out where that short is. What is actually running that so low? Okay, here we go. So I measured around a little bit. All right, and what I found is that on one side of the inductor, we have a problem. So I don't have a short over here. I don't have a short over here. I do have a short over here, right over here on pin 1 of the inductor. Let me just make sure that I'm not talking out of my ass and that really is just pin 1 of the inductor. So I have a short on this side of the inductor, which is, yes, pin 1, which means that this chip is most likely fried. So I'm going to replace that, and then I'm going to replace R6905 again. And this time, that crap had better not die. Okay, so let's proceed. I wouldn't have guessed that. Of course, I want to check orientation. That's another thing that sucks about stealing stuff off of different boards. It's nice, but not only do you have the part there, not only do you know it's the right one, but you know exactly which way it goes on the board without having to consult a board view. It's part of what's going to save you time. All right, so let's see. So on the 20, on this board, it goes pin 4 to 1. And then this board, it goes 4 to... Oh my god, you mean it's actually oriented the same way? You mean I don't have to... Well, gee, now you're just making it too easy. You might as well automate the process of making money. If you're going to make it this easy. These are not the same board. Oh, you're a 2532. Get away. Shoo. Okay. It would have really been smart to see if that short went away before I soldered the new chip. That definitely would have been the smart thing to do. My iron's too small to get in that little cranny over there. Don't let your desk become a mess. Keep things orderly as best you can. Short is still there. Oh. Oh well. Okay, time to figure out what's causing the short. So this is just going to be a little... This is a rabbit hole. You knew you were sending a rabbit hole, didn't you? Okay. And our time may be up for today because my heating element decided to... Ah, never mind. Okay. Well, let's not even bother removing this inductor. There's no point. We're going to take 3 volts. We're going to solder that 3... We're going to solder a wire that's going to be carrying 3 volts to the side where the short is. And then all right, so there's where the fun begins, right? See my power supply in the corner over there on top of the left speaker? Friggin' microphone wires. Ugh. So we're going to turn this on. I have the wires coming out of my desk. So what we're going to do with your board is we're going to start blowing it up. Yep, that's what we do here. Okay, so we're going to take 3 volts. So the green wire here is ground. I'm going to explain what I'm doing here in a second. And then this wire over here is 3 volts. So what I'm doing, so on one side of here, the power is shorted to ground. So there's a component that's not supposed to be doing this, that's taking the power and bringing it at that point directly to ground. Whatever component that is going to become boiling hot because it's going to have all the power going through it. So I'm attaching the 3 volts of this power supply to the ground of the board. But since the ground of the board is tied to that through a component, the power is going to go rushing through that component. And whatever component it is going to get boiling, and you'll be able to see it, and it'll be all nasty. And that will let me know what it is. Come on. Friggin' wires. All right. Current 10.238, infinite. I'll start the voltage at 1. So right now we're putting out virtually nothing. I'm going to up it a little bit to 3. So at 3.4 volts, I'm putting out 0.4 amps. Okay, that's a boring short. Not much that's going to get done there. One of the things I'm going to do for safety is I'm actually going to remove that inductor. because I'm going to up the power here to see what's shorted, but I don't want that to mess up the rest of the board. We're just going to take this inductor. We're going to put the inductor aside for later. Hello. Okay, so let's take a look here at the screen capture. All right, so remember, my short is right over here. So what could be shorting this to ground? Now, I know that back here, in this entire section, I have 12 volts over here and 18 over here. So I'm fairly good to go up to as high as, let's say, 12 volts on here to try to find the short. And if there is a short there, if something is meant to blow up, it will blow up at 12 volts. So that means that whatever was causing the short might have already blown up so quickly that I didn't even see it. But let's see if that is still present. So I'm going to remove this little wire that I put here and do my measurements again. And if there's some, and it's gone. I can't explain it. Okay. Okay, so now I'm starting to get a little confused. Put the inductor back on and see what the hell is going on here. This doesn't make any damn sense. All right. With the inductor back on, let's just check to make sure I don't want this to blow up and surprise me. So the short is back on both sides. So it was on the other side all along. Yeah. Thing is, if there was a short on the other side of the inductor, then how the hell was I getting 2 point something volts before? With the short that terrible, I would have been getting nothing. All right, so right now on my multimeter, yeah, there is definitely a short on the system side. Okay. What is creating that short on the system side? Voltage 3.42 on. And it's only bringing 0.5 amps. So at that, you're never going to find the short with 3.45 amps. I mean, there's some waiting to be done here. Could it be that little one-wire component that I put on that I took off of another board was bad? Tell me that's not it. If I remove that little shit, does the short go away? No. So that wasn't it. All right. So, this one's going to be a challenge. Did I solder the resistors on wrong? Feedback? Wonder if C6999 is bad. See over here? C6999. Where are you? And what do you look like? Anything's possible. Even though it does look good. Nope, we're still at an 11 ohm short. There's a bug on my mouse. Oh, the warm season just kills me. Okay, so sadly, it does look like waiting for this to actually find it using temperature is the best option. It's easier to tell which part of the board is hot in the winter time when my office temperature is like 47 degrees. So turn it on. It's 3.4 volts at 0.5 amps means we're putting a whole 1.7 watts into the board. Less actually, because we're. Oh yeah. Oh yeah. This is gonna be great. This is. I'm gonna find the short in the board by dinner time. That's how this is gonna go. I'm gonna give this a few to get hot because. Does anything want to burn me? A stupid little audio cap, maybe? Yeah. Nothing wants to burn. Okay, so this has a bad MCP 79. So the part that's getting hot is the MCP. So I'll show you what that is. The part that's getting hot is this. So to give you a little information on why I now consider this a bullshit job, that chip is not available new. It isn't. So what I'm going to have to do is I'm going to have to go dumpster diving to try to find one of those that works. Assuming that it works, that's right there 40 minutes to an hour of work. Assuming that when I replace that thing that it's actually going to work and that I'm done, that right there, that's about 40 minutes to an hour of work. And if it doesn't work, every single time I have to try a new one of those because the dumpster dive one that I had didn't work, that's another wasted hour. So this, back to the bottom of the pile, and I will get back to doing other work. And again, I will finish this video whether it works or not, but yeah, right now, bottom of the pile. This is why old stuff can, again, I'm breaking my 20-minute rule here, but of 20-minute sessions, which I shouldn't be breaking. But okay, so I'm going to finish this board that I said yesterday was becoming a rabbit hole. Usually I would completely stop at this point because this is going to be a complete and utter waste of time for a number of reasons. The first reason is that the chipset, so as I said, the MCP79 MXT is what is shorting the PP3V42 rail to ground. First things first, this chip has not been made for 6 years. So any of the chips that I'm going to put on here are chips that were scavenged from a dumpster somewhere that are 6 years old, which means there is a very good chance of them not working. And secondly, with all the problems with this piece of crap board, there's also a good chance that even after I replace that, if that chip is actually good, that it still doesn't work. And with regular stuff, I don't care because, replacing a QFN, replacing a small BGA package, these are all things that take about, 30 and 70 seconds, whereas this takes 40 minutes. But I'm going to go through with it just to get a point across that rabbit holes are a very, very bad thing. Ugh. So first things first, I'm going to prepare the board by removing the junk epoxy shit around the MCP. So it has this stuff. You see, you probably can't see. I'm sick today, so I'm not going to be going nuts with camera angles here since I don't feel good. But yeah, that epoxy stuff obviously has to come off. All right, so I removed the junk around the chip, that epoxy stuff, off the camera because it's frankly kind of boring. So what I'm going to do now is I'm going to cover certain parts of the chip of the board that don't really need to get hot before I start. I'm not going to make this a really super detailed BGA video because I already did one. Yeah, that's my scissors right over here. I always manage to lose scissors. So we're going to cover the CPU. I have no need to heat the CPU. Cover the RAM slot since I have no need to heat the RAM slot. You don't want to wind up killing people's RAM slots, again, in the off chance that this actually works. I know I shouldn't be negative, but it's really hard to not be negative when you're working on something that you're putting like a 6-year-old chip on that didn't come from a real vendor. It's like, because there really are no vendors for this stuff. There's just it's not like you can just go to NVIDIA's website and find an authorized distributor and buy an MCP79. Like it's dumpster diving, which is one of the things that it just makes me tired with this business. Because it doesn't really matter if you can know what you're talking about, you can know how to fix the problem, you can know what the problem is, and you can understand the entire system and still be screwed because, again, you're just kind of dumpster diving to find anything. So, and we put this tape on top as well. I put the Captain tape on first because this tape leaves a lot of nasty stuff on the board doing the adhesive when it gets hot. So I put the Captain tape on first because the adhesive from this aluminum-looking tape is not going to get all over the board and be disgusting. It's going to make the Captain tape, which I'm ripping off anyway, disgusting. Okay, so my board is ready. I'm going to set this thing up to remove the chip, and I also have to see and get myself a good view in the camera here. Might as well move the camera a little bit so you can see. All right. I forgot that I put a when I was using the power supply to find the short. I left a solder blob in one of the board holes. Obviously, got to get rid of that before I can lay it in the machine. See right there, I soldered. This is the old Hacko type, so it takes forever to heat. Really long. Okay. With this kind of stuff, by all means, take your time. in order for it to record, I have to have it plugged in here, so I got to walk back and forth to see what it looks like under there. There's some of the junk and epoxy, but that's all going to get cleaned up and burned anyway. So we're just about ready to start. One thing I have to do, because I don't want to get cancer, is move the fume extractor from here to there. Cancer is not on my bucket list. That thing always manages to fall in the worst possible spot. Surprised it didn't hit the stop recording button on the keyboard. Okay. This is some Kester 951. It's a good liquid flux that I put under the chip because it's going to make it easier to remove the chip from the board. Problem with these syringes is that it's impossible to push it just a little bit. By the time you push it, it winds up sending the liquid everywhere. Ah, I forgot to turn this on. This stuff smells like shit. Whoa. Yeah, plugged the wrong thing in. Great job, genius. Okay. Here we go. Make sure everything's aligned again. I'm not saying that you should take 6 hours to replace one fucking chip. There are people that take 6 hours to replace one chip. But take your time with this stuff. Don't rush it. Don't fuck it up. Make sure everything's where it's supposed to be. And now we wait. One thing that sucks is the Seiki. It has no input lag at 1080p, but it has crazy input lag at 4K. And also that little Magewell capture dongle also has lag as well. So what I'm watching on the screen is like the desoldering process. I'm watching it about a second after it actually happens, or 2 seconds. So it'll get a little heated for an extra second or two. No big deal. I lost a little suction thing that I used to lift the chip. See if I have another one of those. If not, I'll have to use tweezers because I sure as hell don't trust that cheap bullshit suction on the machine to do it. So that's the thing. Not only is the suction kind of weak on the Zalmal, but it also doesn't come with the little rubber piece that you would actually need for it to grip the chip. So unless the chip weighs almost nothing and is barely attached to the board, it never sucks the chip up. And I know it's not going to suck this one up. So I'm probably going to do something that you should never do. So this is one of those, do as I say, not as I do things, where I'm going to lift the chip with tweezers. The thing is, the reason I can do that and you can't is because I can actually see whether it's melted really, really well. And you can't see that. So, if you're using a high-end camera like this, then you're fine. But most people are not. As you can see, the Kester 951 is moving around. Luckily, you can see and not smell, because that smell is atrocious. Yeah, so none of the stuff I have here is good for that. So that little piece most certainly did disappear. Hello, where'd you go? Where'd you go? Time to open the bathroom window and fan because yeah, fume extractor is great, but that still smells like shit. You know when the little suction thing is going to make itself available? It's going to show me where it is right when the profile is done. All right, so we're at 200 degrees. We should start to see some melting happening in about a minute. Melt. So we're up to 215. Still very far away from a point of melting. Okay, so now we're going to 218, 221, 224, 230. So very soon we should start to see some melting. So some of these are melting. Not all of them yet. Okay, give it another 5 seconds, I'd say, and then we lift. Of course, it doesn't lift because the manual vacuum on this is shit. We hit stop. Again, what I just did, you should never do. I hit manual cooling. Now I'm going to use my iron here to clean the area. First, I'll toss a little bit of flux on it. Not a bunch, just a little. I gotta wait for this piece of crap to heat up, though. I have the junky old Hacko 936 over here. So I don't actually have the soldering iron touching the board. I have the leaded blob of solder touching the board, and I'm running it around all this flux that I put on there. I don't think I put enough flux. I put just a little more. The whole idea here is that leaded solder is going to be much easier to pick up than this lead-free shit. And the whole idea here as well is that this is a good thing to do while the board is still hot. It's going to assist in picking up all this shit. But now it doesn't want to pick up, so I got to get a piece of tape or something that I can roll that crap onto. Now we wait a little bit. You shouldn't mess with the board while it's still hot or pick it up. So we wait for this to go back down to room temperature. Again, this is the thing with the chipset. Like, people don't get why I don't like working on the older boards. If this were simply a matter of, oh, I'm just going to replace this chip in 30 seconds or a minute or 5 minutes, and then I'm done, that's one thing. But this is a real waste of time. So I mean, if this winds up not working, this will be a complete waste of almost an hour. So we're almost back down to a reasonable temperature. So I'm going to clean the board on my desk. Just get the air filter back over here. This water is probably filled with carcinogens by now. We're just going to toss that out here. Change the tip on my iron. Beep. That cable will always be tangled. There's really not much I can do about that. Yeah, I should just give up. I don't know why I keep even trying to unwind this thing. All right, so okay, you suck up the cancer. And I'll pick up the solder. Important thing is I'm not going to go nuts trying to get it clean right now. I really just want to get most of it off of the board. So what you're going to find when you're doing this is that the wick likes to slide around and not go exactly where you want. Don't care right now. We're going to use the smaller tip in a second to get a more accurate removal of all the little junk that was left behind. I know you can't see anything here, and I'm sorry, I just don't feel like moving the camera. There was another video for BGA rework. There's actually two of them. One's in sync, one's out of sync, where I show you the exact process and you can see everything in the. And I zoomed in on the cleaning process. So if you just search my channel for ZM-R6200C, which is the name of my BGA rework machine, you'll find that I've already done a video showcasing this entire process. I think it's one of the only videos you're going to find on YouTube with BGA rework from start to finish. No edits, no bullshit, no stupid techno music. Yeah, that is gross. That's water, that's flux. Hey, stole my alcohol. Oh well. Methyl ethyl ketone, this'll do. This will clean. What to tear you open with? Broken screwdriver. Okay. I should be wearing gloves for this. Probably. Yuck. Gross. Okay, this. You're always gonna find some. Send them in. Hey, long time no see. Give me 1 second to finish this thing. I'm recording myself while I fuck it up for YouTube. I'm this. Okay, so a friend of mine came in, so I got distracted, and I didn't do the cleaning, finish it while I was on camera. I finished a lot of it talking to him. Honestly, a lot of this is really monotonous bullshit, like doing this and this and this on a board over and over again to remove crud and crap. That's not really what I find fun. So, I'm sorry that I didn't do it all on camera, but at the same time, if there's a way to make that go by faster, I am all for it. So now we're going to put the new chip on the board, and we're going to see if this winds up being a complete rabbit hole after all. So let's just get a view of the Zomo. We're going to put this on there. We're going to try to align the chip. You're not going to see the alignment of the chip, but you saw it in the other video, so you should be fine. All right, we're going to... Now, even though this is a split vision system, and you can call me an idiot for this, I'm fine with it. For some reason, even with the split vision system, it's out of alignment in the little camera over here. Even when I think the board is level. I don't know if part of that is because there's nothing in New York City that's actually level. A good part of it may be that there's nothing in New York City that's actually level. So, you're going to put the chip, you're going to vacuum it. Let's see if the vacuum will work today. Okay. Okay, so that is way off. We're going to put the chip into place the way it's supposed to go. Okay. And of course, it's way off. Okay. Anytime it requires making something straight, it's just been a weakness of mine, or making something so that it's aligned the way it's supposed to be. It's a real weak point. I mean, I'm not good at that. Like run this wire straight, put this air screen on straight. It's not something that I can say I'm really much good at. So this looks pretty aligned to me. So now I got to make sure that the camera's little microscope camera that I'm using to watch the side of it is in the right place. So over there, you can't really see shit. All right, so all right. That looks bad. Too much light, too little light. Okay, so they look aligned. That picture looks like crap. I don't know why it looks like crap. I'm sorry. It does, and I just kind of want to get this over with. But I can see that it's aligned, so I'm not going to go and going nuts to get the camera to look better for here. Still looks a lot better than the camera that comes with the Zomo. Analog cameras belong in the trash, whether it's for CCTV security or BGA rework. All those like 300 line blurry piles of shit, just 200 line blurry piles of shit. They belong in the trash. Okay, so we're gonna put this new chip. Who am I kidding? This new chip that I bought from somebody that I'm confident would never sell me merchandise that was not absolutely, positively, 100% new in box, direct from NVIDIA. Yeah. If- And if you believe that, I have a dry box to sell you that's excellent at repair on liquid damaged phones without removing the shields. Oh, yeah. Okay. Let me just try the camera one more time. It's hard to because I'm using the monitor that's all the way over there so you can see this in open broadcaster. So I got to kind of turn my neck a lot. I don't know. I can see the pad, and I can see that more than one pad is aligned. So I'm good. But I just have to fuck with it. I can't leave well enough alone. It must always. We're going to turn the air conditioning on so that it's always circulating air. Even with the air filter, it does get to smell like crap in here when you're doing that all day. So let's put this MCP on. Again, I really wish I could have some optimism that this would actually work, but all these chips get sold by pieces of shit like L2 and other people where you really have no idea if it works until you waste an hour on it. One way to find out. Okay, let's see what it looks like if I give you a view of the whole office. Do that. And now you can see the tape that's hanging off of the ductwork. And the wire for this is the analog security camera that I haven't taken down. I really need to clean this place up. But I'd much rather spend that time doing videos and watching balls melt on the screen. So it's going to be a few minutes. This machine takes about 5.5 minutes to do a full profile the way it's set up now. And we're at 1.5 minutes. So it's only, the top temperature is only set to 50 Celsius. Nothing's going to happen just yet. Should also move this so that it's a little bit more within the realm of the nozzle. Put this up a little bit. So at the end, when I see it start melting, I want the ability to, make sure that the middle melts. So what I'm going to do is I have the nozzle a tiny bit up from the board, and once I see that it starts melting and it's dropped, I'm going to drop the nozzle a little bit to up the airflow to increase the temperature and confirm that I've melted everything. Damn, this is boring waiting. If I had a wireless microphone, I could sit in that spin. Okay. BGA rework sucks. It really does. This is boring. Complete waste of time. What do you think, Sharky? I agree. You're losing your mind. That's right, Sharky. I sure am. Ow, Sharky. You really shouldn't be playing with your phone doing BGA rework. You should be watching the balls melt. All right, let's see where we are on the camera since I see the flux is starting to do something. Let's see. 205 Celsius. And we're at 266 seconds. At about 350, 360 seconds, I'm going to expect to end this. It's about like 6 minutes in. Just how long it should take to do this. I look short when the camera's up there and pointed up. It's not good. No good. I'm short enough already without optical illusions making me look even smaller than I am. Much better. So that's not solder melting that you see, that's the flux activating. The funny thing is you're actually watching it in real time and I'm not. Because the TV at 4K has an input delay and the Magewell dongle has an input delay. So I'm actually watching this on the screen 2 seconds after the soldering occurs. All right, where are we at? Okay, we're at 245 right now. So now I gotta watch for balls to be melting and for the chip to drop. Okay, it just dropped into place. Okay, now give it about 10 seconds so that the center balls melt, which means I'm going to bring the hot air down, turn the nozzle up a little, and get those center balls melted. Let's see where we are in the profile. We're 352 seconds in, which means we're just about done here. So I hit stop in the profile. Then I put the air all the way up. I hit manual cooling. The profile is done, and now it's going to be cooling off the board, and the balls are going to be drying. The only thing more boring than watching paint dry is watching solder balls dry. There, you see that? Drying, 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 drying. Yeah, the top temperature is down to 112, bottom is down at 888, infrared is at 92. And again, one thing to understand and realize with this is you don't want to pick the board up from there right when it's done. Give it some time. Wait. You have to be patient because you want this to actually work. Again, even though, as I said, the odds are against me that this thing actually does work when I'm done with spending 2 hours on it, you don't want to do anything to ruin it. When the board itself is 250, 300 degrees Celsius, anywhere around there, and you're picking it up and you're moving it around, you're dropping it on a desk, what do you think you're doing to all those little components? What do you think you're doing to the internal pathways inside the board and the traces and the vias that have all been heated by the infrared? It's just wait for it to get to like room temperature. So I'm going to wait until all of those temperature things over there say 35 Celsius or so, which means I'm going to go to the front of the store and bother other people and hit stop on the video. Okay, so the last thing left to do to finish this crap up is finish up the part of the one-wire circuit that I was working on. So as you can see here, ow, why did I just do that? I did take off that little piece of the one-wire circuit just to see if that was causing any of my issues with PP3V42_G3 hot before, prior to realizing that it was an MCP issue all along. So I am going to put a U6901 there. Come on, camera. Let's find one. All right. My basic little logic gate. Remember what this does from earlier in the video. This is what's going to allow this is going to send the power to the chip that allows the charger to talk to the SMC. Steal it from here. Yeah. Really? You're the new heating element. Okay, so the new heating element I just put in this thing just decided to die on me. So let me put this down for a second. I replaced it. See, this is my old one. Paid $50 for this piece of shit. All right. Hacko, you know all the nice things I say about you. You're making me look bad. This heating element's like 5-6 years old. It's been beat to hell and beyond. All right, so let's see. Turned it off and turned it back on. Let's see when this decides to melt solder. for melting solder, which means I can go. Okay. Charger. See what I get. No green light. Let's see. So according to this, I have PP3V42 at 3.4. And that the VIA for that chip, it's also 3.4. Maybe I destroyed the logic gate? I think I heated it too much. Let's see. I don't think I soldered that properly because I'm tired and sick. Beep. Okay, now here's where we look and see what's going on since I still don't have that. Okay. No greenie. Wait a second. I forgot this was worked on by somebody else. So check, motherfucker. All right, check this out. So that's there. So you know there's two components to the one-wire circuit. There's the one that sends the power to the chip that allows it to talk to the SMC, and then there's the chip that actually has it talking to the SMC. Look over here. What the fuck? Why? You're sending me on a wild goose chase for nothing. Motherfucker. Okay, so let's... Okay. Rabbit hole to hell. Let's find that little piece of shit on another board. Let's also make sure that the board I steal it off of, I'm allowed to steal it off of, so I'm going to try to steal it from, let's see, 3115. Let's see if it's the same chip. I'm going to steal it from a 3115. Mofo. I was just about to start cursing and throwing things. Okay. If there's no green light after that, this board is getting incinerated. So max 9940 on the 3115. And what are you on the 2530? Max 9940. So max 9940. Max 9940. Now let's make sure that the orientation is the same on here. That phone never stops ringing. Thank God I have people that do nothing but answer it. If I did, I would never, ever show you how to fix a damn thing. So this is on the 2530, U6900. Pin 5 is lower left. I want to open another one of these. Come on, Windows 8. Let me. Okay, here we go. And 3115, where is it on there? I don't have this memorized by heart. I should, but that's not the chip that goes bad. The other one is the one that always goes bad, the little logic gate. All right. So let's see. So it's in the same spot, is it? And is it the same, same orientation, same thing? Okay, so, well, of course you're missing. Luckily, I have more boards with that. Of course, the part that I need is always stolen. Already stolen. Already used. Okay, so we're going to do this. Now, extra points to anybody who manages to not burn the DC inboard plastic. What I'm going to do here to try to not burn Mr. Darby's DC inboard plastic is use some Captain tape. Even though, small little part of me Might just feel like he deserves to have a little bit of it burned for driving me nuts. But that's not professional and that's not nice, so we're not going to do that. So let's cover this up in some Captain Tape. Alrighty. And now for the stealing. My Hacko went off again. I think it's time to finally get myself a new hot air station. This is a new heating element, and the thing's still... Like, it was turning off randomly, so I got myself a new heating element. New heating element, like, it used to... This is the thing. If you had the airflow at 10 or lower and you had the heat up, it would always turn itself off. Now this piece of shit's turning itself off with air, heat at 6, airflow at 15. What the hell? Come on. Come on. Don't make me look like a dumbass for recommending your stuff. I've been promoting Hacko nonstop for a long time because usually the stuff always works, but this is the kind of thing I'm talking about. Like all these little starts and stops. I only have so many times I can start and stop before I lose my mind and take the board and toss it at the recycling bin at the other side. So anything that adds to that stopping and starting is bad because I have a limited amount of patience, a limited amount that I'm willing to spend on one board. So let's get rid of this. Come on, pretend that you're hot. Here we go. That's not really good soldering. I have a feeling I'm going to wind up throwing this Hacko into the recycling bin at the other side of the store soon. This isn't the right tip, but I just want to get myself a green light. 700. Beep. 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 Totally not the right tip for this. Give me a green light before I lose it. Okay. Green light. Any of you chant that with me? Green light, green light. Come on, you motherfucker. Finally. Okay. Yeah, just in case you didn't see that shit. Just in case you didn't see that. See that? See that? That means we're getting somewhere. I don't even know if this thing works yet, so I shouldn't be getting so excited. Yeah, and this is an MCP that I think this MCP came from L2 Computers, so I should not be excited at all right now. But I can't help myself. I'm a little excited, I gotta say. Let's see what this thing can do. We're gonna try turning this pile on. This is more time than you should ever spend on something from 2009. But I just want to get... And that's the thing. I'm going to be posting this video whether I fix this or not. But my point is that rabbit holes are just not worth it. They really are not. Okay, you didn't send it in with a heatsink. Which means I will not be testing it with a heatsink at the moment. We're just going to turn this on really quick and see if this thing even does turn on. That's a good thing to try. So let's see, we got a speaker. See if this thing chimes. A RAM stick. In the top RAM slot, which is through hole, just in case the bottom one is dead. The bottom one is BGA, and a fan. Let's see if this piece of crap can turn on. Okay, let's plug a screen in. The ASDing I'll have to do off camera because I have to put this into a tester machine. So I have a bunch of machines behind me that I have to assemble this into one of them so that I can do that, and that's just a pain in the ass. And to be 100% honest with you, I'm out of patience on this board, so that is going to be done later. What I want to see now is, again, does this work and have a brain, or is something else still wrong with it? Because again, this is an MCP from L2. I'm 99% certain that this is from L2. Which just breaks my heart. So it turns on, it doesn't chime, and it doesn't have a picture on the screen. See, this is why I think BGA rework is a rabbit hole. This is why I think that in and of itself is just such a waste of time. I'm going to check a couple of things like CPU vCore, MCP vCore, and after that, I'm going to call it a day on this because I wasted enough time on it. I may come back to it later. To fix it for this guy, but I'm not going to do it in this session. Again, I said I like to limit my board repair sessions to 20 to 30 minutes. It's a great way to stay sane. You try to solve a problem, you don't solve it, it goes back in the pile. You take a new one out, you try to solve that, you solve it, or you don't solve it, it goes back in the pile. Or maybe that board has 5 problems, you solve 2 or 3 of them, you go on to the next one. It just helps. It helps not have the mind get clogged up. So let's see here. So I'm going to check a few things on this board. Check, let's see, PP. But at this point, I'm done for this for now. And again, this is why, like, some of you people that send in stuff that's 5 or 6 years old, and people will always say, you shouldn't throw it away. It's not bad just because it's old. Well, you want to be the person who spends 2 hours trying to fix it using used parts so that it doesn't work at the end? You're welcome to say that. But until you start actually doing it, keep your mouth shut. So I'm going to check on CPU vCore, we're going to check MCP vCore, and see what we have for all these different things. Really quickly, since no heatsink. Because again, if you think I'm going back there and trying another MCP on this right now, you are nuts. Hell no. CPU vCore is present. Hey, the screen decided to turn on. Maybe it was just plugged in wrong. Maybe I was complaining for nothing. Oh, give me a question mark. Give me a question mark. Once the CPU gets too hot, I'll turn it off. But I just want to see if I get a question mark. Let's make sure you can see it. Because if there's a question mark on this after all the shit that I went through, you'd bet your ass I'm going to want that to show up in the video. Fuck you. Done. Yep. Unplug the charger. Screen goes right off. And this piece of crap will be dead. I think this is a good video to answer the questions that people have in terms of expense and time. Like when I say, I cannot tell you the turnaround time, it really is because of things like this. Again, it is really easy. Again, with people who go nuts on the prices of board repairs and wonder why for wholesale it's nothing lower than $225 plus shipping. This is about 3 hours of time that I cannot bill for, and that really is a part of the pricing of these services. Again, how many things does your repair shop offer where you can literally spend 3 hours on something and not be able to bill for it? Probably nothing. And within the no fix, no pay paradigm, again, this is really the best I can do. And it also, again, it really is why I urge you to avoid the rabbit hole to hell and to avoid problems when you realize that it's just one after the other of issues where you don't know if you can solve it. Because again, with the way this works, it's not like you solved 4 out of 5 problems. That's great. It's there's one problem left, therefore the amount that it's worth is nothing. People will either hug you to give you back, to give them back. People will either hug you to give them back something that works, or they will spit in your face and give you $0 when it doesn't. There really is no in between. And that's why, again, if you notice that something is becoming a rabbit hole to hell, just put it aside. That's why I give myself 20-minute sessions for this. That's how I'm able to stay refreshed, and also how I'm able to get through a high volume of business, being the only one here who does board repair. And that's also why some of these take forever. Again, some people want to know, like, why is this so slow? There are some places that are always slow, and that's not great. But again, when something is not a rabbit hole, you're probably getting it shipped back within 1 or 2 days of it getting here. But when something is a little bit of a rabbit hole, it may take a week. But when something like this, don't be surprised if it sits here for weeks and weeks and weeks as I go through these 20-minute, 40-minute, 1-hour sessions with it and get absolutely nowhere. Because again, you're probably not going to get any further than I am with these, given the same amount of time. So that's about that. So this was a rabbit hole to hell video. This is probably the longest board repair video I've ever done. We solved a lot of individual problems on this board, but in the end, it was just too far fucked. And again, there's a 50% chance that I'm going to go and dig through my pile of garbage and try to find an 820 2530 6.5-year-old SMC, and a 50% chance that I say fuck this and just send it back and give up. But that's it for today.